So on the panel, we have the host, which is Industrial Logic. And starting in the late 1990s, Industrial Logic helped pioneer lean and agile methods in the software industry. Today, their global teams of coaches, trainers, and engineers help organizations across many industries accelerate product discovery and delivery. And this is the second episode in a series of Twitter Spaces that presented by Industrial Logic. Um, we have John Reed on the panel with us. He's one of the coaches at Industrial Logic. John, why don't you introduce yourself a little bit? Thank you.
What up? Oh, I don't know. I'm John. Out here in California. Normally play out in the iOS space, but got a little experience coaching other folks as well, which has been fun.
Also, we have on the panel Anthony. He's also one of the coaches working at Industrial Logic. Anthony, why don't you give a brief introduction and then we'll move forward.
Sure, thanks, Manib. Hi, everybody. My name is Anthony Sciamanna. I've been in the software industry for about 25-ish years now, if you count co-ops as well. With about 15 of those years really focusing on agility and specifically technical agility. So I really love helping software teams achieve great things and kind of getting away from what is the standard form of agile now, which is basically just the way companies have always worked, wrapped with some Scrum terminology. So I really love kind of helping teams achieve true agility.
Dark Agile.
Yes.
That was a great introduction. Thank you, Anthony. For those who have joined, if you want to come on the speaker and interact with us, you feel free. Please feel free to request the mic. The way to do that is there's a microphone icon on the bottom left corner of your screen, and once you click that, you should be able to send out a request, and I'll be glad to accept that. Meanwhile, we have also posted a post on top of the space. The post is about the article or the blog that we are actually going to discuss here today regarding code coverage complications. And Anthony is the author of that blog. So he's here to talk about the topic, give us a pretext, and then we'll go into lead that with a few questions from the audience. So it'll be great if we get some engagement from you guys and you share your experiences on the topic. But before that, I'll request Anthony to give us a bit of a preface on about his blog post. Thank you, Anthony.
Sure.
Go ahead.
Sure, absolutely. Thanks, Manib. So yeah, this is an article. I actually wrote it for the first time a few years ago, and I had it kind of in draft form even before that. And I updated it for the IL blog this year. So it's something that I see over and over again in software organizations. So I guess the premise really of that blog post is that I see software organizations and their teams trying to achieve high code coverage with just this assumption that it's a best practice. And you can't see me, but I'm using air quotes because I'm not a huge fan of the term best practice. And they try to achieve it without changing any of their development practices. And I don't ever see that really leading to really sustainable improvements in code quality. And that's really because high code coverage is really the result of quality first development practices. So it's not a goal kind of in and of itself. So what I see over and over again is that organizations are trying to achieve higher code coverage. They're not changing the way they develop software. So they end up with tests that are slow, that end up slowing them down instead of helping them deliver better software sooner.
By the way, you said tests, and I think maybe it might be helpful to take a step back and explain maybe what is code coverage.
Oh, yes, thank you. That's a
for
good
anyone
point.
who doesn't know.
Right. So when you are so code coverage is a measure of you basically run your tests and you can track coverage on your tests, and it will basically return you number of lines and give you a percentage of the your code base, how much of that has actually been executed by the tests. So you'll get things like percentage, and also number of times the methods have been called. So you can see, right, if there's, one class or one function that's getting called 100 times in your test suite, and then some that are getting called once, right? So it'll give you some of those indicators. So I think the critical thing here is it shows you coverage, but that coverage doesn't actually tell you anything about how valuable that test is. It just tells you that that code was covered when you ran the tests.
One of the funny things I think about code coverage, and a reason people trip over it, is because um, something I like to say is that lack of coverage is definitely true. Like
Yeah,
if something is not covered, that's real. But if it says something is covered, that might be a lie or an accident or um, kind of a coincidence.
absolutely. Yeah, and I think we'll probably get to it in our talk today. Um, Code coverage isn't all bad, and it's also not all good, right? It all matters what we do with the information. And I think when we talk about the good usages of it, you are kind of zeroing right in on one of them, John. Is when you run your code coverage, if you see there's no coverage somewhere, that's good information for you to have. Especially if you're working in a big code base, maybe it's a code base that you inherited. Maybe you're still doing things like, story point estimates for work. Having some information like that when you go in to size some work would be good if you know you're going into an area of code that has tests, or an area of code that has no tests, right? So those are some good usages of it. So I think that is an absolutely kind of key point. It tells you the absence of tests, but just because there is coverage, you have to dig a little further to get better information.
And that information doesn't come from the raw number.
No, no, it does not. That and so I think maybe that is a good kind of uh, maybe that's a good segue into one positive way to use. So if you are going to look at code coverage and you want it to be as valuable to you as possible, I would be coupling code coverage with mutation testing tools, because that's going to show you, are the tests actually testing anything. One of the reasons, we'll probably talk about test driven development a few times today. One of the many reasons why I recommend test-driven development is you have to see every test fail before you make it pass. The thing that I see very common in test after development is tests are written that can never fail. So mutation testing is going to show you that. It's going to show you over mocking, where you're like, I see tests that set up a dependency as a mock, and then they assert that it returns the value that they set up.
Oh,
So
oh,
like,
oh no! You mean basically they're testing the mock?
testing the mock, yeah. Hey,
Ah, yeah,
I set up object, I set up
it happens.
mock A to return string B. Now I will assert that I got back string B from the call. So, those, having something like mutation testing in place will show you, by making small deviations in the code, showing you whether those are caught or not. So I think those two together can be valuable, but there's other caveats with tracking code coverage, I think, in general as well.
At this point, I would like to take a pause and see if the audience would like to, indulge here a little bit. So, if anybody in the audience is looking to speak or share their thoughts or ask a question, please feel free to request for the mic. You can also send out a direct message to one of the hosts or co-hosts, and we can address your questions and comments as well. And I would also like to request you all to kind of share the space. So there's a plus sign blue button on the bottom right corner of your screen. If you click that, you should be able to share this space via a tweet, so we can gather as much people as possible and kind of get get the experience, get to share the experiences with everybody. Um, and with that, I'll pass it back to you, John, so you guys can continue your conversation.
Pass it back to me. Oh no, I'm on the spot. I mean, this is one of my favorite topics, and there's so many ways we can explore this. Uh, thinking. Um,
So one of the things that one of the questions that I had in my mind was, what should we be doing instead of tracking code coverage?
Okay. Yeah, I think that is a great question. I think so. When I'm working with teams or an organ, I guess really this is more of a question at the team level. First is if I get that question, I would ask them why they are tracking code coverage, because that's I may change my answer based on what their response is. So I think one thing. So the common answer is my organization requires it, and that's not a good reason.
oh,
Um, and that is the so we'll talk a little bit about how this breaks down. If not now, maybe in another part of the Twitter space later. But that's one of the ways that it breaks down is when the team isn't actually getting value out of it, but it's just required of them. So I think now, if you're on a team where things are being pushed down from your organization, you may not be in a situation where you can just say we're not going to do this anymore. So I totally appreciate that, and if you don't work in that type of environment, it may not be safe for you to raise those objections. But you're not going to get the value out of it if it's just being pushed on you. Um,
now
what
why would that happen? Like, why does that ever happen? Why why does it become a requirement in
uh,
some teams?
I so my so one, it's a number, right? So people, so when it gets pushed down from the organization, it's a number. I think there's kind of built into it that higher numbers are better, which is actually for code coverage. I actually don't think is true. Higher numbers are better to a point, but so I think there's a little bit of uh, more code coverage must be better. It's a best practice. So I think some of that is coming from organizations that want to be able to take a quick look at, the health of their teams. I do think static code analysis is very valuable, and this often comes with static code analysis as well, tracking coverage and um, other metrics about the health of the code base. So I think a lot of it comes from that. Um, I see lots of organizations have 70% code coverage as a build gate, and uh, my experience, you may be getting value out of having a build gate that verifies that people aren't pushing code without tests. That makes a lot of sense. But my experience with that is that is inspecting for quality. The more that we can shift the way that we work to building quality in, the less we have to do, the less the inspecting that we have to do. So those, like, inspecting for quality slows us down, right? Those are things that stop work and we have to wait, right? Wait for somebody to review the code, go back and try to get the coverage around the code later. So it's kind of built into the old ways of working that we're going to do a bad job and we need lots of inspection points along the way so nothing bad ever gets to production. Kind of the new way of thinking about software development is building quality in. So can we build quality in? Once we do that, we can stop inspecting for quality. So kind of getting back to what I would do instead of focusing on getting higher code coverage, I would be test-driven development is a great way to build quality in. Collaborating at the time of code creation instead of reviewing, right? Getting people together to work on the code. Cross disciplines, right? Get your QA folks sitting with your developers to help them write better unit tests, or what we call micro tests, which we'll talk about, instead of having the handoff black box to QA to just do manual testing, right? Build that quality in. Learn about software design, learn about micro testing, which is a certain type of unit test, and how to build high quality micro test suites. So coming with that's going to be software design skills. That's where I would less focus on just getting the coverage, because that's when you start building test suites that are going to accelerate you. And just kind of as an aside, the best teams I ever worked on never tracked code coverage because they were doing test-driven development. The teams that did test-driven development greenfield, we never bothered looking at code coverage because it was just a distraction. So I think that was because we were doing these quality first practices. We were pairing, we were doing collaborative work, we were doing TDD.
I do find that in general, when I'm doing TDD, coverage it's not an issue. It's just not. And the only times it's helped me are when I have basically made an error in my TDD and implemented too much.
Mm-hmm. Yeah. And that is that could be a valid reason, especially if it's a team that's new to TDD. It could be a good
Could be
thing to
a
be checking. Yep.
right, right.
The other one, well, actually, before we jump down, I use the term microtest. So let me go back to that because not everyone here might not know the term microtest. And I think I think we have a public video on the IL YouTube channel that defines a microtest. So microtest, I can't remember how long the term's been around. At least 15 years, I would say. I think I've heard it for a while now. But the term microtest was developed because every few months there's an argument about what is the definition of a unit test, um, and people come up with their own definition. So the idea of a microtest was to be able to talk about the qualities of tests that accelerate teams, and these are more easily written when you do TDD than test after. So the idea of a microtest, by its name, it's very small. We're talking, less than a dozen lines or so, right? That's a rule of thumb. Just because it's, 13 doesn't mean it's terrible, but they're very small, they're very fast, they're very precise, and they test the micro behavior. So the idea is they never leave the developer's computer, right? They run very quickly, so you can run them constantly. And because they're so small, they're not testing they're not testing a lot of scope in your system. They are much less likely to suffer from false failures, right? The bigger tests, and the tests that we see that are common when you're just trying to achieve a coverage goal, they tend to test more scope. And they're kind of mixing large scope and a lot of detail, which is a recipe for tests that are flaky, right? That they could fail for the wrong reason or pass when really they should be failing, right? The idea of the false negative and false positive tests. So those are really common, and those are things that get in your way. So when you have a test, when most of your tests are these micro tests, that's where you can test all of the branching logic and business logic of your system, and that gives you the power to move quickly.
I actually just got a direct message from one of the folks here who perhaps is unable to get the mic or for some other reason does not wish to, and that's fine.
Mm-hmm.
So the question is, hey, I'm listening on the Twitter space, wondering what's a good metric on how many different use cases on a function or a type are being tested? That is, how do you know when you've flexed enough outputs or enough behavior?
Yeah, so that is a great place to do a coverage test. But where I would do that, and I guess so, maybe I'm thinking in terms of the JetBrains IDEs that have actually coverage tools built into the IDE. If I am developing something and I'm trying to make sure that my different tests are covering those scenarios, and this is presuming that I have code without tests already. So if I inherited some code without tests, I would absolutely use coverage for that. But I may not use test coverage running on the build server generating a report. Where I would start would be running with coverage to see where are the gaps. Oh, okay. There's this guard clause that we never test anywhere, and it's important. We should probably have a test for that.
Yeah, again, finding the gaps or the holes, because the lack of coverage is true.
But if you're doing test-driven development, and again, it's great to be able to, become an expert in test-driven development overnight and have a greenfield project to work on. Neither of those things happen, right? So everyone's at a different point in their learning. So but if you are if you're learning TDD, or adept at TDD, if you can follow the rules that I'm not going to write a line of code, I'm going to start in the test and I'm going to write the smallest amount of code to make that test pass, even if it seems silly or trivial. Once you build that habit, you don't even have to think in terms of, am I covering all the cases? Because you don't write any code without that test case in place. So that's where I've found we don't need to do that. But absolutely, I use coverage, like I said, not like ceremonially, that's a word, right? Like, not that it has to generate a report. Every build doesn't have to generate a coverage report so that the higher ups can see it. But if I'm working in a legacy code base, I am running coverage constantly to make sure, especially if, so there's this concept of pin down or characterization testing in legacy code. So
Yes.
I'm trying to write a test to pin this code down so I can clean it up safely. I'm running coverage constantly to see, am I getting this code? Have I covered all the cases so that I feel confident in my ability to safely refactor that code? And so
Yeah.
hopefully that answered the question. That might be a good, maybe is this a good place to talk about? I feel like we're heading towards a kind of the situations where tracking coverage is a good idea. So
Yeah,
yeah,
let's talk about that.
okay, yeah. So
And meanwhile, for the audience, feel free to request for the mic. And those of you who are joining from their desktops, just to let you know, this feature, Twitter Spaces, is more suited for your to join from your mobile devices. If you want to interact, if you want to request a mic, you have to join from your mobile phone, from the mobile Twitter app, and that way you'll be able to interact with us. Otherwise, you can also listen in on any of your browsers on desktop or on a tablet. And with that, I'll pass it back to you guys.
okay, great. Yeah, so there's definitely times that I recommend tracking code coverage, right? There's no absolutes. I just see it being used poorly more than it being used well. So one situation where I would recommend it is if a team is inherited a legacy code base, or they're trying to turn their, maybe they're trying to learn the new practices and they're trying to get legacy code under test and that's new to them. I think tracking coverage is really important for a couple of reasons. One, that we just mentioned, that it's a valuable tool to know if you're trying to pin some functionality in place, whether it's safe to do so or not. There's otherwise you're just, you have to rely on yourself being able to step through the code, and your computer's going to be able to do a better job of that than you are alone. So that's one case. The other one is kind of rehabbing a legacy code base. If you have a huge, really convoluted, complicated code base with no tests or terrible tests, and you're trying to refactor that code to be more testable and to get better micro tests in place, that can feel very tedious, and it feels like insurmountable at times, because there's all this extra work just to get the code tested. So tracking code coverage and having it be a number that you actually look at every day, like on a team dashboard, I found to be a huge morale booster, because even if you're not making huge percentage gains, just seeing that number going up every day is a big morale booster I've seen for teams. So I think
Yeah,
that's valuable.
I totally agree. I think the way I like to use coverage is as a trend, not as a hard and fast number. It's like I don't really care uh,
Mm-hmm.
what your number is. It might be like 5%. It might be zero. Uh, in which case, getting to one would be like, hey, let's celebrate that.
That's right. Yeah, exactly. So, and that's right. So that's all kind of tied up in starting with, and I realized I used the word legacy code, and a lot of people have their definitions of legacy code. I don't mean anything negative by it, even though I'm sure it has that connotation. I just use, so Michael Feathers, who wrote the book Working Effectively with Legacy Code, he called it code without tests. So that's the definition I'm using. legacy code actually, is quite useful, or else it wouldn't become legacy, right? So that legacy
Right.
usually means that it's making you or your company money, or your company money, and subsequently you also making money from it. So
Somebody's using it.
yeah, exactly. So um, yeah, if you're in a situation where you don't have tests, or you don't have a lot of tests, being able to track that coverage and seeing the trend is valuable for sure. There's another good usage of it that I like. Again, we have to remember that coverage just tells us that the lines were covered and doesn't tell us how valuable those tests are. But there's a metric in some of the static code analysis tools, and it's called CRAP. It's appropriately titled CRAP. It stands for Change Risk Anti-Patterns. And what the metric does is it scores code based on lack of code coverage and cyclomatic complexity. So you'll get the
Oh.
less code covered and the more cyclomatic complexity, the higher the score you're going to get. That, I think, again, if we start from with the idea that we have a code base that doesn't have tests to begin with, or we're just learning how to test code, that can be valuable because it can tell you the riskiest areas in your code to change. So I think that can be valuable as well.
That's really good because um, the biggest bang that we get from microtests is on branches and loops, and
Exactly.
so that's the area. If you have code that's got branching or that has looping and that has no test coverage, then that's more important than this other code where everything just sort of goes all in sequence.
That's right. Absolutely. Yeah. So I like that. I don't know. I don't believe it's default in Sonar Cube. I know for a period of time, it was defaulted in Ndepend, which is in the .NET environment, but I know it's at least configurable in Ndepend. So yeah, it's out there, and there's some blog. I may have actually linked to a blog post about it in my blog. I think I did.
Awesome. Meanwhile, Fazaro has also joined us. Thank you, Fazaro, for joining.
Hey, gang.
Um, yeah,
Hey, John.
What up, John?
what up? So good to see you here. For the audience, he is also one of the coaches at Industrial Logic. Thank you for joining, and would you like to contribute a little bit on the topic?
Yeah. I'm coming in a little late, so I'm not sure if I might be saying something that's already been said. But the thing I think about the most when I think about code coverage is a thing that applies to basically any like one-dimensional number, right? And that's Goodhart's law.
I love
Uh,
it.
has that come up?
Oh,
It's
no, it
almost like
hasn't. Thank you.
it's almost like we planned this. That's the next place I wanted to go.
It's right
Amazing.
there in the blog, isn't it?
It is.
Yeah. So, Goodhart's law just states that like as soon as you've turned a measurement into a target, it's become a useless measurement.
That's right. Yeah, I love it. So what I did, if you haven't seen the blog post, if you go to the blog post, I actually link to, there's a website called Sketchplanations, and they do just like great, simple descriptions and a sketch of what these laws are. And I linked to Goodhart's law. I think that's great. There's another one I didn't link to. It's called Campbell's law, and it's basically a more in-depth Goodhart's laws. And I think that Campbell's law is also on Sketchplanations. So yeah, exactly right, John. That's like when the problems that I see with achieving high code coverage is the result of is kind of Goodhart's law, right? Is that they end up being gamed, and the kind of the premise that I laid out at the beginning of the Twitter space was that the problem is when teams try to achieve high code coverage, but they're not changing their practices at all. So they're still working the same way they always did before that got them no code coverage. And now we just need high code coverage. And that to me is where Goodhart's law comes in, because we don't have any new practices. We're not writing our code any differently. but we have to achieve this high code coverage, and deadlines aren't changing. We have to keep marching forward. We have to hit our velocity estimates or else there's a problem. So what do you see happening in the code base? The most interesting areas of the code get skipped. I've definitely seen tests where they're testing getters and setters. They're testing data objects, but then ignore all the logic. And it's, not the best object-oriented code. So they have lots of data objects and then lots of the actual logic to the behavior that interacts with those data objects is elsewhere. So they skip all of that and they just test getters and setters. So that's not really, we don't need to test getters and setters. We're testing our programming language at that point. And then the one I've told folks here a few times that I saw at a company that I used to work at, massive tests. And the names were great. The names were actually the names of a bug in a bug tracking system 2 tracking systems ago. So the name was meaningless, random letters and numbers, massive test, and no assertions.
Tests
But
without assertions.
Those score super high on coverage, but they're not actually testing anything. So those will blast your coverage numbers through the roof. You'll hit your build gate, your code will go through, but you're not actually testing anything. So those, I would tell, delete that test. No, we don't want to delete that. But those kind of tests are just holding you back. And then, then there's the people that are going to muddle through it, right? They don't work differently. They aren't writing testable code, but they're trying to wrap them in tests. And they're doing their best to, do what's expected of them. And when you try to wrap untestable code in tests, you end up with these brittle and flaky tests. There's a quote, I wish, maybe one day I'll figure out who originally said it, because I use it all the time, but I can't attribute it to anyone. They said, you can't write good tests for bad code. And I think that is like,
wow.
I tell people that all the time. If you have massively coupled classes and you have no boundaries in your system, you can't write a micro test for it. And that's why it's so important to really kind of internalize the value of micro testing. So those tests that you're going to be writing are going to, they're going to be slowing you down.
Wow, that's a really good
chunk
one day
of
wisdom there.
I probably need to reach out to the Twitterverse and see if we can crowdsource the person who came up with that quote.
Yeah, that's what I noticed in your blog, because I read that quote, but underneath it said unknown.
Yeah, I have no idea. It
Yeah,
might actually be
this is
somebody
bringing
at
up
IL for all I know.
This is kind of bringing back a little bit of post-traumatic unit test syndrome for me. I'm remembering my earliest experiences trying to write unit tests, and it just, like, the best way I could sum it up is it feels like doing your big sister's homework, or she's going to beat you up. Like, I don't know what's going on, I don't know where to start, and it's all terrible. Like this, just like, and I'm thinking about unit testing versus test-driven development, which is when it finally, made any sense to me. But especially if you don't have code that's testable to begin with, that has boundaries that you can lock into, there's just no direction. You're supposed to cover the thing with unit tests. Now go do it. And
right.
There's so little direction to that you end up with these terrible tests and maybe great coverage.
Yeah, and it's a miserable experience in the process.
Yeah, it is, but it does bring back memories. I feel like that's a important point of learning that you have to get to, is to say, oh shoot, maybe it's not the test that's hard to write, maybe it's the code that's resisting me.
Right.
Awesome.
So you mentioned at one point in your blog about writing tests without business value increases risk for the organization.
Oh,
How
yeah.
it will...
Yeah. Okay, good. That's a great topic. I didn't even
Exactly. Yeah,
forgot that was there. Yes. So So there's this idea of it's called opportunistic refactoring. It's a blog post by Martin Fowler, and kind of the analog to that is the Boy Scout rule, right? That you go in, you always leave the code cleaner than when you found it. And opportunistic refactoring is the same idea from Martin Fowler, which is we improve the code that we're currently working in. So whatever the business value is, right? Whatever the features we're working on for our, to deliver value to our customers, that's where we refactor. So the code that gets visited the code that gets visited more, right, gets changed more, gets improved more. So that's great, but also there's other areas of the code that maybe don't ever get touched. Well, they don't have to be improved because, right, that code is already in production, regardless of how you feel about it or how hard it is to change. It's already in production. So we introduce risk when we have to change the code. So if we can build in the habit of improving the code when we go to change it, that's this idea of opportunistic refactoring. So I take that same approach with getting tests around existing code. So one of the things that I've seen, this is another kind of thing that I see time and time again when teams track code coverage, and when it's being kind of foisted on them by their organization, like you need to get to you're at 30% code coverage, you need to be at 80% code coverage. What's going on? These other teams achieved it and you haven't yet. One of the things that I see is projects that get built, that are like increased test coverage in this area, increased test coverage in this area. So they're spending time and money just writing tests around code. And I think that just increases risk, but there's no business value there. So there's no reason to change that code, but you're writing tests for it. And kind of what Michael Feathers coined as the legacy code dilemma is that to get tests around existing code, you often have to change that code to make it testable. So you're either going to just try to write tests, which I saw one organization do, and if you're just trying to write tests for untestable code, they're like, you're not allowed to touch a file that doesn't end in test, was what one of the managers said. And I'm like, well, you're going to end up with a bunch of terrible tests then, because there's only so much you can do with that. Or you're going to start changing production code, and but there's no business value. So you're increasing risk and spending money, but there's no reason to change that code right now. So that's my take on it. I would rather see teams improve the code as they get to it, and that helps build that habit.
Hey John, could you mute when you are typing, because we can hear all.
Oh shoot! I'm sorry.
We can hear all
Wow,
of your
clickety-clack on
keystrokes.
my, and I had it right there. Oh, whack it, whack it.
So
He's just working really hard at getting the code coverage up.
Geez,
Multitasking.
I had my mute backwards.
So that's my take on it. Now I know, right, that sometimes we do that because if the team hasn't built those habits to incrementally improve, having the project do like the project improvement seems like a great idea. But the problem like with that is that doesn't build lasting habits. John Fazzaro and I are doing a training, a workshop together, and we talk about intensity versus consistency. That project is intense, but it's not building consistency. We get the benefits of these practices, when they become our habits, the things that we do every day.
Absolutely. So at this point, I would like to request the audience. We would love to get some feedback, some opinions, some experiences, and we would love to hear, what are some of the horrors that you guys have been seeing in test suits when you're trying to achieve high code coverage. We would love to hear back from you guys. So um, please feel free to request for the mic, come on the speaker, and share your experiences with us. You're open to ask any questions to the coaches that are on the panel. So I think one of the speakers has joined us,
Yeah.
Bruno. Thank you for joining.
Yeah.
Yeah, what do you have to say?
Okay. Thank you. I'm currently in London, and next week I have to start a huge refactoring. Well, I would like to add something when I think it was John or no, it was no, not John, but something about when you change a code to make the code testable. Generally, we don't modify the behavior, but just some part of the code to be testable. And the risk exists, but it's not so big. And that's the first point. So the second point is about starting and refactoring. Um, Generally, when we start a refactoring on the big application, the problem is code is very difficult to understand because developers have no idea of the business rules. And at the end, we have a very procedural code with a lot of dependencies. But the problem is business person have no connection or don't want to speak with a team developer. That's the second point. And when I started to refactoring a big application, the first thing I try is to visit the code with the team and ask people with some knowledge on application. And we try to discover, sometimes it takes a week, the functionality in the code. And we write on the post-it on the back of the team every word we understand. Maybe it's not correct, maybe it's correct, and we make some assumption with comment. We put comment in the code, and we try to verify it's true or not. And we after that we write a very big test, acceptance test, to see if we can put this test. It's not necessarily possible directly because we need some time to break dependencies. But after sometimes 2 days or 3 days, it's possible to find a way to put the first test. The second test is easier. At the end, we have a lot of tests, and we can start to rename. The first thing I do is I rename. I don't move the code immediately. I try to put a meaningful name where we are confident with the name. That's my way to refactor, and I don't care about if I cover correctly all the code, but only the code I have an interest. That's my point.
Excellent. Yeah, I think that is. I think your approach is a wonderful one, and I really like the idea of trying to find people who. I think one of the problems with legacy code bases is the experts are sometimes no longer there. So if you can find anyone that can help kind of make sense of the code, and one of the things we like to talk about is the code base is implicit, right? A lot of times it's tangled, it doesn't have good names, like you said. So there's knowledge in there, but it's implicit, right? It's not explicit. So the
Yeah.
more that you can do to make it explicit, like you said, with naming, giving it good names, that is fantastic, and it's a great first step. And I think the other point that you made that I think is valuable, that is worth repeating, is you don't have to cover all of it. You just have, if you can, one of the things we talk about when working with legacy code is if you can identify your change point where you need to change, you just have to start with getting that area under test. So you don't have to test everything. You just have to test the area that you need to change. So I think that's a really valuable point that you made that's worth repeating for everyone. And then your first point was about getting. I'm trying to remember. The first point was getting
it under test, or
with that,
writing the first test was one thing that popped out at me. That writing the first test can be hard.
Yeah, absolutely.
Hey, Peter, could you please go on mute? And we can come to you next.
Yeah, one of the things that I like that, Bruno, you made me think of is there's a wonderful article by Arlo Belshi called The Core 6 Refactorings. And he talks about them being the Core 6 refactoring because he says they're the ones that are most useful when you're working in like a legacy system. And it's all about you can do some of these safe refactorings if you have the tooling, and you're careful. You can do some of those refactorings without tests. So that, Bruno, your point that, when you go in to make the code testable, you might have to change it without test, that legacy code dilemma. If your tools support those core 6 refactorings and you're careful, you can start some of those without tests. But a lot of those core 6 refactorings is about giving good names to what the code is doing. So I think it's a really great article that I usually recommend to everyone. I think Arlo is really great, and I think he summed up a lot of really good points in a relatively short article.
Yeah, the core 6 is good. Another thing we've mentioned before, but that you kind of described, Bruno, is like when you're writing tests up for legacy code, one of the challenges is you're trying to figure out what does this code do. But there's a way, often a way to test the code, to bring the code under test without even understanding what it does. And that's using Michael Feather's technique called characterization tests, which is basically to say whatever the code does is correct. Or that's the behavior we don't want to change. So let's just throw a bunch of inputs at it, and whatever it spits out will capture that in a test. And this wonderful tool called approval tests, which is available in various languages, also makes this even easier. It sort of does all that work for you.
Yeah, I know approval, and I use approval at the very, very beginning because my objective is to discover the behavior, and because the behaviors I bind to functionality. And I would like to add something I don't say, because I'm also in a DDD community, and I use event storming just before to start the refactoring. Event storming with all people concerned by the application to try to understand together what's the motivation, what the application is doing actually. And generally, we discover a lot of things before to look the code. And after that, we start to discover, and we also use sticker when we discover something we never heard before. And we try to discuss with people in charge of the application if make it sense or not. That sometimes
what the heck
we
is this?
discover something nobody heard before, but it's a life of software development. But yes, event storming should be helped before to start, and approval test is very usable at the very beginning. But after, I prefer to write acceptance test with a very good name to understand and to qualify the acceptance test.
Great.
All right. We also have Peter on the speaker panel. Peter, please unmute your mic, introduce yourself, and ask your question.
Yeah, hi, I'm Petar from Serbia. So I wanted to just briefly, because this was mentioned, I think, in the beginning of the discussion, like where does the requirement of coverage come from? And I think that it all actually springs from the misunderstanding of the use of tests, because I think the larger portion of the community considers tests as sort of a safety net only once you write the code, so that you actually, if you ever need to change it, you'll be able to, because you have the tests. But when you actually change the perspective and you view the tests as sort of scaffolding that guides your development and the design, that's when you actually, as Anthony said, with test-driven development, then you actually don't really focus on the coverage, because you don't care about the coverage. You care about building the next piece that is supported by your structure that you've built so far. So I think then there is this whole idea, okay, in the industry, we need the tests in order to keep our code maintainable. And then people write tests after they wrote the code, and then they feel more secure if they cover it, like every line of it. And I think that's basically what I wanted to add. Thank you.
Yeah, that's great, Pilar. Thank you. Especially like the maybe the worst type of tests are those that aren't really about behavior, but are locking down a particular implementation, and then those tests actually go against what we want, which is to make change easier.
That's right. So I will forget who said this, but someone said it's like pouring concrete on your code base, and I love that. I love that analogy. I wish I knew who said that. But it's true, and that I think that's one of the dangers of. I think you can do it either way, but it's certainly more common test after if you do test after testing. That you end up testing your tests are more coupled to implementation, but you certainly can do it with TDD as well.
Yeah, with TDD you get it out of the box, or at least the portions that you need. But I think that the test after is, I don't know, maybe it's just my bias, but I think that test after is prevalent in the market, in the industry.
I'm afraid you're probably right.
Yeah, my experience is definitely way more test after than test first.
Agree. It's a shame.
It's also an opportunity, I guess. Opportunity space.
There's a good positive attitude.
That's right. Peter is closer to the weekend than we are, so it's good. He's more positive than we are.
Yeah.
So I see Dustinson in the audience. Just for everybody, he's also one of the coaches at IL. He was at the Agile 2022 for the whole week, and he's just been having so much fun. So I think he's just traveling back and listening to us from the airport. And he just texted me and said hi to everybody here.
Yo, Dustin.
Hi, Dustin.
So we would love to hear from others in the audience. So please feel free to take the mic and share your thoughts with us, share your experiences with us, give us feedback.
Good experiences, bad experiences, confusing experiences.
Hey, Dustin's on the mic. Hey, Dustin.
Hey guys, I'm having fun jumping in, listening to the conversations here. I was curious if tests after development is prevalent. Why do we think that is?
Well, dude, that's a whole talk in itself, isn't it? Why are we here? But it's a good question.
I'm just gonna put that grenade and walk away.
I was actually kind of
last 5
thinking about
minutes.
that, and like I wonder if it's just the prospect of, you know, the skeuomorphism of something testing. You're testing something; it has to exist first. So test-driven development is inherently, or test-first development is inherently counterintuitive. And so that's, it's the emphasis on testing, and so much when I'm teaching TDD, I have to unwind the fact that it's not about testing; it's about development. It's not development-driven testing, right? So it's if the emphasis is on testing, it makes sense that most people are trying to do it after they've written the thing that they're going to test.
When we start coding, most of the time, quite often people are working in an interpreted language with a REPL, where you can just sort of type something and then see the output. And that's fun and it's rewarding and it's a great way to get immediate positive feedback that like programming is fun. And I wish teachers all over at all levels, starting from elementary school, would then say, okay, great, look, you just printed hello world. Now, how can the computer check that you printed hello world? You just checked it with your eyes. Are you going to check everything with your eyes every time? I don't think so. Not when it gets complicated.
I'm curious as well as there's the comment, how can we test something that doesn't exist? But the idea exists. The idea of I want to start the app, have a context of nothing, and then see hello world. I mean, that's an idea that could be tested, right? And then realize when the code is written.
We can do this. We can get people going this direction. It's just that there's such a flow of new developers coming in, I think, that haven't been taught that.
Yeah, I think what Fazaro said is key to it, is that if we think in terms of the what's valuable about TDD or testing in general is the artifact, is the test that you end up with. It's easy to think, maybe maybe I'm dating myself, but I learned none of this in when I went to college or university. I learned all of this after the fact. So we weren't really taught any of this. And when you're thinking of testing, you're thinking of, I write some code and then I hand it off to QA to test my code. Well, maybe I write some code and then I write some automated tests for that code. And then maybe I still have to hand it off to QA because we don't work together. So they aren't going to trust what I do. So if you're just thinking in terms of testing, it kind of makes sense to follow that I'm going to test. I have to test something that already exists. So I think that's a big part. I also think that it's hard, right? XP. How old is XP now?
How old is XP now?
9. So when did the first edition of Extreme Programming Explained was either 97 or 98. So it's been
like
around for a long time, and
25
a
years.
lot of people are still not doing it. So I think it's a hard thing to do. I tried to teach myself TDD before I worked on a team that did it, and I just could not grok it. And it took actually working with people to do it. So I think it's easy to say that you do a stand-up. It's not so easy to be successful at TDD, right? So I think part of it is that too, is that it's kind of unwinding the way we think about writing software. So you really need practice, and practice with experts is probably, for me, was the best way to do it, to learn it.
I think when you become a pro in TDD, you never code without TDD. But you're right. If you want to become a TDDist, you need to practice kata during maybe 2 months or 3 months, twice per week. You should come better in TDD. And we should said also there is 2 schools in TDD. TDD for microtest and TDD for acceptance test, London School. So in the real life, London School is more useful than the microtest Quebec style. And also, if you need to practice correctly TDD, it should be good to have a good user stories. With a good user stories with criteria acceptance plus concrete example, TDD become very easy, and you spend a very good time to write a code.
I think one of the things that makes it challenging is all these practices reinforce each other, and they don't start taking off until you start building up enough talent in each of them. And it's when they come together that the real fun starts.
All right,
Yeah,
we are actually moving towards the closing time for the space. Would you guys agree? If so, we can go towards like some closing remarks and then kind of end this.
sure. Yeah, sounds good, Manny.
Awesome. So Anthony, would you like to close this? Any closing remarks, recommendations?
I would say if you are struggling with code coverage issues and you're not feeling like it's actually a benefit, go check out. Yeah, go look up Goodhart's law and Campbell's law. See if that's see if if code coverage is just an obligation or you're getting value out of it. And if you're not getting the value that you expect, I would say go back and look at some of the practices that build quality in, because kind of rehashing what I said earlier, my experience has been the more that we can focus on the practices that help build quality in, we can start lessening those kind of points in our process where we have to inspect for quality. And certainly measuring code coverage is one of those activities to try to inspect for quality at some point in our process. So I would try that, and then just remember it's not all good and all bad. So just if you're going to use it, just know what it's telling you and try to use it. Wield it properly, right? So maybe couple it with mutation testing, and you'll at least get some more value out of what it's actually telling you.
Awesome. I'm opening up for the panel. Anybody wants to add any final remarks? Go ahead.
Another plug for mutation testing, which I have yet to have the privilege of working in a language that has automated mutation testing support, but that's okay. I do it manually, which means I will deliberately break something in the production code. For example, change an and to an or vice versa, or add a not, or comment out code. And the thing you want to see that happen is that a test fails. And if that happens, then you have extra confidence that your tests are actually helpful.
Awesome. So with that, I'm gonna go towards Anthony. You're saying something?
No, I'm good.
Oh, okay. So I'm just gonna end this by saying thank you to everybody who joined as a listener or as a speaker. Just to let everybody know, this was the second episode in a series of Twitter Spaces that Industrial Logic is going to host. We're going to be actually addressing some of the blog posts that are written by the coaches at Industrial Logic, and we basically want to discuss those topics and have an interactive session with the audiences and share our experiences via this platform. So please follow the host, follow the co-host, follow each other, and look out for our invites for the spaces. We'll be doing this every Friday at 2 p.m. Central. So look out for the invites coming from the host Industrial Logic, and we'll see you guys next week.